given 50 kg ammonia and 100 kg oxygen gas are fed to a batch reactor, determine the limiting reaction and extend the reaction and percentage access. Let's write down the equation for this reaction. In this reaction, 4 mole ammonia reacted with 5 mole oxygen to produce 4 mole nitrogen monoxide and 6 mole water. Then given 50 kg ammonia, we can find out the mole number by the stoichiometry and the molar mass. From chapter 2, we talk about the unit consistency. We know that kilogram is in the same group with kilomole. If you want to use kilogram, you gotta use kilomole. If you want to use gram, and then use mole. So in this case, it's given kilogram, so we're gonna use kilogram per kilomole. And the molecular weight for ammonia is, we can round to 17. So we use 50 kg ammonia in the fresh feed times 1 kilomole over 17 kg ammonia. We get 2.94 kilomole ammonia in the fresh feed. And do the same thing to oxygen. 100 kg oxygen divided by the molar mass of oxygen get 3.125 kilomole oxygen. And based on that, we can use a Chimax to find out the limiting reactant. Chimax based on ammonia is the mole number in the output stream. In this case, let's assume there's no ammonia in the output stream because based on the reaction, there's no ammonia. Let's say reaction goes to completion. Then the final mole number for ammonia is 0 minus 2.94 kilomole. That's what we find out in the fresh feed ammonia. Divided by the coefficient, we say that coefficient for a reactant is negative. So in this case, coefficient is 4, so put the negative number is negative 4. Then we get 0.735 kilomole ammonia for the Chimax. And do the same thing on oxygen. Let's assume the same thing, oxygen go to completion, so there's no oxygen from coming out of the output stream. Then we say the output mole number for oxygen is 0 minus 3.125 kilomole in the fresh feed of oxygen. Again, oxygen is the reactant, so the coefficient is negative number, so divided by negative 5, then you get 0.625 kilomole oxygen. Then compare these two numbers. 0.625 is less than 0.735. Therefore, we can conclude that oxygen is limiting reactant, and the extended reaction is based on limiting reactant, so it's 0.625. Remember, the limiting reactant determine the external reaction is equal to the mole number minus the mole input divided by coefficient. Then you will get, in this reaction, the external reaction is based on limiting reactant. So use the same number as the Chimax based on the limiting reactant. And the mole number of ammonia reacted is based on the limiting reactant, given 3.125 kilomole oxygen for the limiting reactant, because we say oxygen is the limiting reactant. Then for every 5 mole oxygen, there is 4 mole ammonia reacted. So based on the coefficient of the reaction, we can find out the mole of ammonia reacted in the reaction. Therefore, the molar reactive for ammonia is 2.5 kilomole. And because oxygen is the limiting reactant, therefore ammonia is excess reactant. Therefore, the fractional excess, we know that from the formula of fractional excess of species A is equal to the mole number of A in excess divided by the mole of species A reacting with limiting reactant by stoichiometry. From this reaction, we can find out how to use it. So we found out the mole of ammonia reacted with oxygen is 2.5 kilomole. That is based on the limited reactant by stoichiometry. And the mole of ammonia in excess is simply the moles of ammonia feed minus the moles of ammonia reacted. Therefore, it's 2.94 kilomole in the fresh feed minus 2.5 kilomole ammonia reacted. Then you get the mole of ammonia in excess divided by the mole number of ammonia reacted with limited reactant. In this case, it's 2.5 kilomole. Then it's asking for percentage. Therefore, times 100%. Then you get 17.6%.